Hello and welcome to another episode of Cloud Security Podcast with Virtual Coffee with Ashish. If you are here for the first time, each week we talk about a cloud security topic with an expert from the field. This month, the topic is bug bounty in Google Cloud, and the topic for today is finding and fixing bugs in Google Cloud. Towards the end, our episode gets live on Cloud Security Podcast website, which is coming at the bottom. And if you are new to this channel, consider subscribing so you get notified for episodes like this in the future. And if you're watching on LinkedIn, hey, feel free to connect and follow the Cloud Security Podcast page over there where you can see parts of this. Now, before we get into the actual crux of the episode, I do have a couple of sponsors that I want to thank you for making this happen. And I'm going to start with Exonius because Nathan does it much better than I do. So here you go, Nathan.
Hey, Ashish and Cloud Security Podcast listeners. Thanks for giving Exonius the opportunity to sponsor the show. Exonius does exactly three things. By connecting to existing data sources, Exonius gives customers a comprehensive asset inventory, both cloud and on-prem. It then uncovers security gaps, and finally, it automatically validates and enforces policies. Thanks again, and check us out at exonius.com.
Thank you, Nathan. And time of the hour when I can bring my guest on. So I'll put my music for cue. Hey, welcome to the show, Dylan.
Thanks for having me.
Oh my God, I am so excited about this because I wanted to kind of get into the weeds of bug bounty for a while. Last year we did one episode, actually a couple of episodes, one with BugCrowd, which you're also a member of, and spoke about what does it mean, what is it like. And today I'm super excited about talking about what does it mean specifically for Google Cloud, and why not get a professional hacker come and talk about this as well. So for people who may not know you, and by the way, before I get into this is a tradition. Cheers, man. Thanks for coming to my virtual coffee with Ashish. Yeah, cheers. Oh, you got a Netflix club. Oh, that's nice. But what are you having?
You know, I saw a couple of your videos. People are bringing beer and water and all kinds of stuff. I feel like you got to respect the medium. It's coffee with Ashish, so I gotta get coffee with Ashish. Yeah.
Yeah, perfect. I appreciate that, man. Appreciate that. And so for people who don't know you, we've got people coming in. Hey, Zainat, and hey, Vineet as well. Welcome. So for people who may not know who Dylan is, I guess who are you, and how do you reach your professional hacker status?
Yeah, that's a really good question. So for a while, I was like a little bit under the radar. Didn't have the social medias, wasn't out there too much. So I've done a bunch of stuff in my career, but it's kind of hard to find if you if you try to Google me. I did a little bit of work in consulting. I've done a little bit of work in politics. And then I was on the application security team at Salesforce for a little while. Most recently, I was on the application security team at Netflix. I've done a little bit of public speaking for security research that I've done. I've done a little bit of bug bountying. And I also have open sourced a whole bunch of tools, the most popular of which is a tool called TruffleHog. And most recently, I actually founded a company around that community.
That's pretty awesome. And we definitely need to touch on TruffleHog a bit as well, because it's definitely relevant for a wider audience, not just the Google Cloud audience as well. So, hey, RK, thanks for coming on the show as well, man. And I'm going to start with the first question. This is something that we ask all our guests, and I love to hear people's perspective on this. So I'm keen to know yours. What is cloud security for you?
Yeah, so for me, I really break it down into two major categories. The first category being identity and access controls, and the second category being secrets management. I know there's a lot more to it, but those are like the two main ones that hit home for me.
Perfect. And it's a very short and succinct answer as well. I love it. I was going to ask, because we're talking about finding bugs, and it sounds like you touched on bug bounty as well. We may have a few people who do not know what bug bounty is, and something called responsible disclosure, considering all the movies that I've watched, none of them talk about responsible disclosure. So what is bug bounty, and what does it have to do with responsible disclosure?
Yeah, so I will touch on bug bounty from two different perspectives, both from the perspective of a company and from the perspective of a security researcher. From a perspective of a company, it's a mechanism to encourage researchers to go out and find vulnerabilities and to compensate those researchers for those vulnerabilities. And in doing so, it also allows them to control the narrative and impact of those security vulnerabilities. And then from the researcher's standpoint, it's basically just gig work. If you're a hacker, this is a way that you can define your own hours and you can make some money on the side. If you're really good at it, there's some people that make hundreds of thousands of dollars a year doing bug bounties. And if you're pretty new to it, there can actually be a little bit of a learning curve there, because there's a lot of security researchers out there that are incentivized and you're competing against them.
Oh, awesome. So, and what's the relationship to responsible disclosure?
Yeah, so responsible disclosure is sort of the superset of bug bounty and other things. It's basically just a mechanism that's sort of endorsed by the company as a means to disclose security vulnerabilities. And so if a company has a bug bounty, then you can be financially compensated for responsible disclosure. If a company doesn't have a bug bounty, they may still have a mechanism for you to responsibly disclose vulnerabilities to them. And that might be an email address or it might be a form submission.
Wait, so is there an option like this for Google Cloud? Is that how we find bugs? We start with responsible disclosure for Google Cloud? Is that how we start?
Yeah, so Google Cloud, or actually Google as a whole, has a mechanism for you to report security vulnerabilities to them. And within that, Google Cloud has a piece of that carved out where they will financially compensate researchers for vulnerabilities that are unique, that they triage and decide to action on.
Right. So I guess for anyone listening who wants to probably kick it off first, they probably should look out if there's a responsible disclosure program and then start exploring that a bit more. And I definitely want to get in some of because you seem to have shared quite a few vulnerabilities. Well, I guess depending on how you look at it, I don't know would you call them bugs or vulnerabilities, but you found a few on the Google Cloud side. And I'm curious, what got you into looking for bugs in Google Cloud versus, I don't know, AWS or anything else, I guess?
Yeah, it was a little bit opportunistic. I mean, I guess the real story is there's a friend of mine who works at Bird, the scooter company, named Mark Newland. And one day I actually shared a Lyft ride with him home. And he just told me a bunch of really eye-opening things about Google. He's like, yeah, everything runs as admin by default. And I was like, what? And then he just started explaining more and more. And I'm like, this is not how I understand clouds work. Please tell me more. And then I eventually, took it home and did more research on it, and then pulled in Allison, and we did a whole bunch of research together on it and presented on it a few times.
All right. And shout out to Allison as well, who co-presented with you a few of the bugs. So, okay, I've set the scene for folks now, and I'm pretty sure they'll skip all the chapters to the ones that they enjoy when they watch this again on YouTube. But with the first one, which is an interesting one for me, was the metadata API one. And what is a metadata API for people who don't know? And is this the same as AWS? Yeah,
that's a good question. So I think the lead in here was I did a talk at B-Sides on the GCP metadata API. At a high level, cloud instances, so like Lambdas or Cloud Functions or EC2s or virtual machines, they get their identity through an internal API. And what I mean by that is when you assign a role or assign permissions to one of those instances, that instance then is able to use those roles by making a request to an internal IP address, fetching credentials, and then using those credentials to hit public APIs. So the metadata API is basically just an internal IP address that you can hit from an instance in the cloud that gives you credentials, and those credentials match, the access to those credentials match the role that you've assigned the instance. It's very similar to AWS. They also have an internal API. I think the IP address is different, but other than that, the functionality is almost identical.
Maybe worthwhile exploring why you may be one of the reasons why they added headers into the Google metadata API.
Well, so actually, let me clarify that. So there was somebody named Will Benstein who used to work at Netflix. Now he works at HashiCorp, and I think you actually had the pleasure of interviewing him not too long ago.
Will's an awesome guy.
Will sneaked in headers, which basically prevent a type of vulnerability called server-side request forgery most of the time. But there was one exception to that you could still, in Google Cloud, abuse through a headless browser. And to close that loop, what I did was I suggested they added host header validation. Basically, it's a specific header that browsers can't modify. Browsers can modify other headers, which is why Will's protection didn't quite cover this use case, but they can't modify the host header. And so what I was able to do is add the suggestion that they validate the host header so that we could close down that last avenue for SSRF, or at least known avenue, I should say.
Yeah, and to your point, I think it's worthwhile calling out as well, right? So pre-adding the headers and once people start using the API, the whole conversation and the common use cases that you come across in the industry is someone leaves their credentials on a GitHub repository or, I don't know, on a Stack Overflow forum somewhere. And you kind of, once you identify them, the whole SSRF conversation was something that people would just like slam it everywhere. Was it that straightforward that, and I'm going to play a bit dumb here. So if I have access to someone's keys in Google Cloud, to identity keys, or to a service account in a Google Cloud, I can use that to access, like in the previous version of the non-header version, I could just hit the API and get any information that's related to that particular credential that I have. Would that be accurate description of the, I guess, SSRF and how it can go beyond just that?
Not quite. So let me rewind a little bit and define
Perfect.
what SSRF is for folks kind of new to AppSec. And so this is kind of the confusing part, is because a lot of my research has blended together application security with cloud, and so we need to kind of cover a little bit of both. And so SSRF is server-side request forgery. Basically, it is just a mechanism for it's a vulnerability that enables a anonymous user to send requests from the server on behalf of the user. An example feature that could introduce an SSRF is something like a feature that allows you to upload images, and you could specify a URL and they'll fetch an image from that URL. And so the reason why it's a vulnerability is if the attacker specifies an internal IP address instead of an image, and then that server will go and fetch from that internal IP address and return it to the hacker, then in this specific case of the metadata API, it allows that hacker to get access to credentials that are supposed to be internal only. You could also use SSRF to fetch just general sensitive data. If there are sensitive services behind a private network that the hacker can't access, they can use this SSRF to jump into that private network. But in a cloud setting, it's often scoped and referred to within the metadata API context. And Will Benstein did a bunch of work with Amazon to get them to add a required header, which would not be present in the feature that I just suggested. So if you have a feature that you specify a URL that fetches an image, that extra header wouldn't be tacked on. And therefore, the metadata API would not return an API credential. And so Will was able to close down a large swath of SSRF in the cloud context just by getting Amazon to add that header. And then Google copied Amazon and also added that header.
Oh, right. Okay, cool. Thanks for explaining SSRF as well. It's always good to play dumb sometimes. And maybe talk about so are we saying that the headless browser vulnerability that you kind of explained in your talk that you referred to, is that completely gone since the header has been added? Or actually, maybe if you can explain that a bit more, what it was?
Yeah, so this is going to get really tricky because it's going to go really in the weeds of application security, and I hope that's okay. Basically, browsers are beasts. They are really complicated beasts that have a long legacy of weird rules and restrictions. One of them is the same origin policy. And I'm sorry, I have to dig in a little bit and explain what that is to be able to fully explain this vulnerability. Basically, a browser is meant to be able to visit a website, and once that website runs JavaScript, the JavaScript on the page can make that user send HTTP requests. But there are limits to what those requests can do and where they can go. And those limits are defined by the same origin policy. Usually the rule is, unless another website allows you to, you can't send a request and view the response from a different origin. So if you go on google.com, Google can't, on your behalf, steal a bunch of your Facebook data and then do something with it. So there's these rules, these limits on origins. So there was a feature that a Google project manager did a blog post on, saying you could run a headless browser in a cloud function in Google that allows you to basically take a screenshot of any website you want by providing a URL, and that cloud function will run that URL in a headless browser and then screenshot what's ever there. That includes running all the JavaScript on that website, doing whatever that website says. So, you might think, okay, well, that sounds a lot like SSRF. Let's just specify the metadata URL and you'll be done with it. But the problem there is it expects that header to be there. And so if you just type in a website in a browser and hit enter, it's not going to set that metadata header. And what gets screenshotted will not include a credential. So we have to be a little bit more creative. And so what I ended up doing was I had this browser make a request to evil.com, we'll call it. And then I served a bunch of evil JavaScript. And what the evil JavaScript said was make a request to myself, to evil.com, and then take that content and render it on the page. And the reason why I did that, and this is, again, deep in the weeds of browser security, the definition of an origin in a browser is the protocol, the domain, and the port. And the reason why I mention that is the IP address does not fall into the definition of a origin. And the reason why that's important is if when the browser does a lookup to resolve the domain, and it points to evil.com, and then evil.com says, make a second request to myself. And the second time it makes a request, it does a second DNS lookup. And that time an evil DNS server responds saying, actually, my IP address is an internal metadata API IP address. The browser will be tricked into thinking it's talking to the same origin because IP addresses aren't a part of origins. And it'll successfully be able to view the content from the metadata API, and then we can render it onto the page. And I know that was a whole bunch and probably more than you bargained for, but that's the crux of how that vulnerability was able to evade the protections that Will Benstein installed at AWS and the Google then copied around that extra header check. And the way we protected against it at Google, the suggestion I made to them was to strictly validate the host header, which is automatically set by the browser and can't be modified by JavaScript, so that if they did make a request to the metadata API, it would say evil.com, and they would be able to check that and say, this is evil.com, this isn't metadata API, let's drop this request. And that was the extra protection that was added, and that was the loophole for SSRF that was still possible in Google Cloud when I reported the vulnerability.
But it's no longer there anymore.
As far as I know, that loophole for browsers has been closed, but I definitely encourage other people to take a look because I can't guarantee that every loophole is closed. There's always fun research to be had.
That's pretty awesome, man. And thanks for, I guess, laying it out. I know I definitely encourage people to check out the actual talk as well. I'm going to link that in the show notes because I love the kind of way it was explained in a simple way that you did just now, because there's a lot to digest in there, but it was still simple enough to know that, hey, a browser should not be making a call to the backend Google Cloud, I guess, metadata API, unless it actually knows it is unless you trust the origin, you should not be allowing the metadata to kind of respond to it as well. I think I'm taking that as the big takeaway from this. So glad to know it's been primarily closed or kind of closed. Will encourage anyone who's listening probably to just go in and well, I'm going to say tinker, but do what you think responsibly. I should be very careful when I mention this, I guess. And to RK, your question, yes, I think I'll add this in the show note as well. So the doc has a lot more information, but I'll definitely add that in, man. Thanks. So that was the first one. And I think the way I'm going to approach the show is I'm going to talk about a few more that he released, just to kind of talk about what the bug was and how people can solve it as well. Maybe, I guess, how people can limit the exposure. So the next one that came to mind was around the service accounting. And I'm going to probably go into a bit more on the Google Cloud territory. So maybe we can dumb it down for people who may not have Google Cloud exposure, but no AWS, which seems to be the bigger market player at the moment. There is this whole concept of service account in Google Cloud. And there was a specific vulnerability that you spoke about from a Google Cloud service account perspective and the permission it has and the owner. So I've thrown a few words here, and I would love for you to kind of get into like, what did you identify as a use case for service account and the owner, and where it kind of, in a large organization, people just get lost in there, I guess.
Yeah. So I think, Allison and I worked carefully on how to do the best introduction to Google Cloud. And where we settled was basically by just comparing it to AWS, since most people had exposure to AWS. And basically, the way we broke it down is in AWS, access controls are identity-centric. And what I mean by that is you can answer questions like, what does this identity have access to? The policies for what can do what, it's centered around an identity. In Google Cloud, that's flipped on its head, and access controls are actually centered around resources. So you can answer questions like, who has access to this resource? And the resource owner controls who can access that resource. The identity owner doesn't have control over that narrative, which is the opposite in AWS, where the identity owner sets the controls for the identity. In Google Cloud, it's the resource owner sets the controls for the resource. And all that's a long way of saying in Google Cloud, if you have an identity, you can't answer questions like, what does this identity have access to? It's unanswerable by design, because resource owners decide whether or not that identity can access their resource. And you may not have permissions to be able to even see what that policy is. And so you can answer questions like, who has access to this resource, but you can't answer questions like, what does this service account have access to? In AWS, it's the other way around. If you have an identity, you can very easily be able to answer, what does this identity have access to?
Wow, is that by design?
It is by design, yeah. And I talked to some of their PMs about that, and I think the reason why they built it that way is just because that's how they did IAM internally at Google prior to Google Cloud. And so they just copied the same access control model over.
Right. So a resource owner can define who can access, but me with the identity, I would not know what else do I have access to. Like, how much do I have access to?
No, so you won't know and you can't know. It's sort of by design. There's no way for you to know what that identity has access to, because any resource owner in the universe of Google Cloud, even if they're outside of your organization, can grant it access to their resources. And you won't be able to see that. If you don't have permission to those resources, you can't see the IAM for those resources. So you really don't know what your service accounts have access to.
Wow. I mean, sounds like the GCP permission model may be a bit more open than AWS one.
Well, so that decision is important for understanding how GCP IAM works, but that decision by itself, I wouldn't say necessarily opens things up But there were a couple of other decisions that made Google much more open than AWS. One of them was what I mentioned before when Mark Newland told me in the Lyft ride home that the defaults in Google Cloud are just very permissive. If you spin up a VM instance or you spin up a cloud function, by default, it'll get an identity attached to it that has almost full administrative capabilities, which is the complete opposite in AWS. If you spin up a virtual machine or you spin up a Lambda function, it won't have any identity attached to it.
That's right. Yeah. Wow. It's just like, so yeah, I mean, I guess as a security person listening to this, you're going, that's a bad idea to begin with, right? Just like, why? Okay, so I get a lot of permission that I probably may need, but not necessarily need. So, okay, I'm with you on that one. Okay, so, and maybe adding a use case to this then, talking about service accounts, and maybe if you want, we can go to take the GKE path as well, because we had, last month was Kubernetes month in Cloud Security Podcast. So we did a full month episode of just Kubernetes security in general. And we had Kelsey Hightower from Google Cloud as well. He came and gave a talk about the Kubernetes space in general. GKE sounds like, and taking what you just said, if I start a GKE cluster, I'm getting a lot of permission that I should not really need. So, and I think you did like a use case on this as well. So keen to know if you can unpack that a bit for us as well.
Yeah. So first, I'm glad you mentioned that you were in touch with some folks over at Google. I got a lot of friends over there, and I think Maya was leading the Google security for GKE for a little while. She's great. A lot of the security features they've added are awesome. I think a lot of the things I'm about to speak to are inherited debt. And what I mean by that is when they created GKE, there were constraints that were baked into the cloud they just had to deal with. Some of them are like that default I just mentioned. And so I just wanted to caveat everything with that there's great people over there, and we shouldn't just toss blame around like there's lots of people that are making the story better. But to answer your question about GKE, by default, GKE runs on top of a bunch of virtual machines. And so by default, those virtual machines will get that very permissive identity attached to it. And what that means is, by default, if you run workloads in GKE, unless the default has changed since I've last looked into it, those workloads can hit the metadata API because they just run on that VM. And so they have the same networking unless you change your networking by default for your workloads. And they can pull that identity and get lots of permissions to your project. I think there's some, I think they call them scopes that they drop onto the instance by default that gives you lots of access to storage, but maybe limit some of the other things you can do. But those scopes are often opened up because people want their workloads to be able to access more APIs. And then on top of that, just full access to storage for every workload is kind of scary by itself. So the reason why I've had so many caveats in place is because they've implemented a lot of awesome features that lock that stuff down, but you have to opt into them. And one of those features is at a high level for the entire organization, you can just turn off that administrative grant for new projects. It's not retroactive, it's proactive. And so if you create new projects, that administrative account just won't get attached to things like VMs by default if you enable that policy. And then within GKE, you can enable something called workload identity, which for every single workload you have running in GKE, it then gets its own identity instead of using the node's identity. And that's really powerful because if all the workloads are sharing the same identity, you have a whole bunch of developers that are just slapping all kinds of permissions onto the node. And you may have many different developers deploying many different workloads, and you end up with everybody sharing the same identity and the permissions just getting crazy. So they rolled out workload identity, something you can opt into, which allows each workload within the node to get its own identity, to get its own metadata API credentials, and to be able to segment that. But it is not enabled by default. You have to go in and enable those settings. And if you're just playing around with GKE for the first time, chances are you're not going to get those things out of the box.
Oh, interesting. I love the context then. So you're basically, and if you tie this back to what you were saying about identity earlier, where as an identity owner, I would not even know that you've given me permission, excessive permission. And just on that, I don't know if, I think I've got a question from Zenith over here. If there's a version of IAM permission boundaries for GCP, do you know the permission boundaries? I can probably explain what it is, and you can probably tell us about the GCP version. Essentially, it's like it's a permission boundary you can allow for. I think Dylan's role is of an SRE, and this is the maximum permission that he can be allowed. That's the simplest way of putting the permission boundary. Is there like a similar thing in GCP?
So the thing about GCP IAM is it's a little bit of a spaceship. There's lots of controls, lots of levers, lots of dials. There's one control called scopes, which allows you to limit what an identity can do once it's attached to a resource. So I kind of hinted at that before. And then there's another control called conditionals, which basically let you do all kinds of stuff on top of permissions. You can say Ashish on the third Tuesday of every month is allowed to only access this one bucket. And so you have to take all these things in tandem to really understand what your identities can do. And a lot of them are like opt-in. You have to be an expert at IAM to figure them out, and the defaults are open, but you have to kind of enable them after the fact. But I think those two are probably the closest analogy to the AWS feature you just described.
Oh, right. Perfect. Yeah, because I think AWS has something called conditions as well, but this definitely makes it definitely, I don't know if you can actually do the whole every Tuesday of the month thing, but it sounds pretty awesome that you can actually go down to that kind of layer. Hopefully that answers your question. A good question as well, Zena. Thank you. So we've kind of spoke about the GKE and overtly permissive, I guess, pods or nodes that can get access to. And I can kind of see this could be quite, how do I put this? It can be quite overwhelming because you almost look at this and go, okay, Google Cloud, even though the security team in Google Cloud is trying to do their best, but they have a lot of tech debt that they're trying to kind of work around while trying to remain secure. There was another one that you mentioned, which was actually quite a surprise for me, which was the whole cloud build role. And if you could probably touch on what that is and what was the scenario that you and Amanda kind of spoke about, that'll be awesome as well.
Yeah, so like I mentioned, there is a metadata API that instances have access to that allow them to fetch credentials to get access to a credential that has permissions that enables it to hit a public API and do stuff, right? But what was interesting about Cloud Build and a couple of other APIs is, Cloud Build is a build service for Git. So if you have a Git repository and you commit to it, it triggers when you commit to it, and then it runs a build based on what your build file tells it to do. But you don't see a VM and you don't define any permissions, just kind of magically in the background, something runs somewhere and it puts together whatever you tell it to put together, and then it can publish artifacts to your project. And so what we did was we said, okay, well, if something's running somewhere, and typically everything in Google Cloud, when it's running, can hit a metadata API, let's just add an instruction to the build instructions to wherever this mystical thing that's running, tell it to hit the metadata API and see what comes back. And a credential came back, which was interesting because we set up Cloud Build in a project with no service accounts, with no roles, no permissions, nothing. We just set up Cloud Build, attached it to a Git repository. And then within the Git repository, we just added an instruction in the build steps to hit a magical metadata API that runs on some mystery instance that we never see. And all of a sudden a credential comes back. And so, the first question we had is, what the heck is this thing and what does it have access to? And we dug into it a little bit, and we found that it is something called a Google Managed Service Account. So they created it, they manage it, and they created the permissions for it. And then when we looked at what those permissions were, it could do a bunch of gnarly stuff, including stuff around storage and artifacts, like you'd expect this magic thing in the middle of nowhere that can write to artifact stores would be able to do. And so it creates this scenario where people are totally blind to it, where maybe you have this Git repository, and maybe you've set up write protections around a sensitive branch. but you still allow builds to happen on the non-sensitive branches. And maybe you've, in your build steps, said, okay, well, the sensitive branch, that gets published to production, and the non-sensitive branch, everybody has the ability to create branches and write code, and the build steps will still run, but there's no publishing that happens. But what this enables someone to do is, if they can push code, even if it's to the non-sensitive branch, they can still fetch this credential and then all of a sudden get access to storage for the entire project. It enables them to publish to production for those artifacts, and it also enables them to snoop around on whatever else you have in storage for that project. And that just is not at all transparent to anybody, really. And so we really thought that this would be a vulnerability. And when we wrote it up, the response we got back was actually it's not. They didn't view it as a vulnerability, and so that capability is still there. And we weren't the first to report it, and we weren't the last to report it. There have been others that have done public write-ups. There was one Rhino Security published on the exact same thing. And so there's just identities that you can basically fetch out of thin air that have weird permissions to stuff that, undocumented. And Cloud Build is one example, but there were a couple other examples we found as well.
That's awesome. And for folks who are listening in who are from an AWS background and are suddenly going, that name sounds very familiar. There's an equivalent service in AWS called Code Build. And exactly pretty much what you mentioned. And I'll encourage people to try and see if the code build that they write is making a call to the AWS API, metadata API. Because I think it's fun. One thing we didn't mention with the whole metadata API is that people who are using the older version, they have to upgrade to the newer version with the header, right? It's not like, header's updated. Isn't that right? Like, I can't just say, it's all resolved now, so it's not a thing anymore.
I feel like Will Benstein is the person who should tell this story, but I'm going to channel my best Will Benstein and try to explain the way I understand it worked out. Basically, Will pushed really, really hard on Amazon to get them to add this header. And Amazon's response, as I understand it, was basically, but everybody's using the old version of the old libraries that doesn't have this, everything would break overnight, right? It's just like you're using an old library that doesn't set the header, the Bodo 3 library. It's like it wouldn't set the header and cloud identity wouldn't work anymore. And so Will, as I understand it, sent pull requests to every library you can think of, adding capability to set this header, which was awesome. But the response from Amazon was basically, okay, now that all the libraries have the capability, folks still need to go in and enable it and then activate that capability within the library, bump the version of the library, pull in the version that sets the header and all that. And so that's the way it worked out in AWS. And then Google copied all of that functionality. So it was the same thing. They had a version 1, then they rolled out a version 2, but you had to opt into it basically.
Yeah. And it's one of those moments when you as a security person go like, it's like this could have been. I'm so grateful, by the way. Shout out to Will Benstein. I'll appreciate people giving him a shout out for the work he's doing on making sure others are getting the benefits of the hard work he's putting in, probably not getting noticed for it as well. So thanks, Will. If you get to listen to this, I'm gonna give him a shout out on the posting as well. So I'm glad we are kind of on this juncture where we kind of spoke about some of the bugs that you identified, and we've kind of given some inspiration for people to kind of check out some of the AWS equivalent and see if these vulnerability, weaknesses still exist, because it is a legit thing to call metadata API, right? It's not illegal to call the metadata API. That's why it does exist over there. They don't really say, hey, you can only call it from point A to point B only. There is no definition for it. So someone who's poking around in terms of whether these things are equivalently, available or possible in AWS as well, is this illegal, or is this like, what is this like in terms of legality?
Amazon has a responsible disclosure policy where they write up what you're allowed to test and what you're not allowed to test. But as far as I know, they have no public bug bounty for AWS. I think they might have one for Amazon.com, but I don't believe they have. I could be mistaken, but I don't believe they have one for AWS.
I haven't seen one either. So, because I think there's an AWS security email that you can send a bug to. Like if you go to the AWS security page and they talk about, hey, if you do find a bug, report it to this email, which is like, Yeah, sure. Like probably never hear back from them after that, I guess, but you'll see. So I'm so glad we've kind of covered that, and we're kind of just crossing the halfway point as well. So I wanted to kind of touch on some of these things as well, because you do have exposure on the other side of bug bounty, and as in part of running it, and like from a blue team perspective. Because a lot of people who may be listening to this like, oh my God, these people are possibly great people to be hanging out with. They should share more information. So keen to know from you, what was your experience on the other side, like the whole responsible disclosure, or like what was your approach, and what was your experience as being on the receiving end for a bug bounty?
Yeah, so AppSec usually sits at this weird purgatory that's not red team, it's not blue team, it's just kind of its own thing. And AppSec also can often encompass a wide range of things, from software development lifecycle to pen testing to bug bounty. So when I was at Salesforce, I was on the AppSec team, and my team ran the bug bounty. I was a little bit involved, although not as involved as the person that was primarily in charge of it. And then at Netflix, that responsibility was fully shared within my team. And so I would just rotate on a PagerDuty schedule, and everyone would share, this is your week where you're running the bug bounty, and then next week it would be somebody else's week. So I do have, a bit of experience triaging bugs and sitting on the other side of the table, kind of talking to researchers and those types of things.
And this kind of brings me a point then, should everyone have a bug bounty program?
So there are some very good there's some very good stories about certain companies that went full crazy with a wide scope public bug bounty, and it was too much for them. They received too much intake, it was too much spam, and they ended up getting more bugs than they knew what to do with. And some of them took years to close out, and it created bad research experience. So my recommendation, and this is from me personally, if you're thinking about bug bounty in your company, first and foremost, you need a responsible disclosure policy. You need a mechanism so that when people find vulnerabilities, they can disclose them. But if you're thinking about bug bounty, if you're thinking about compensating folks, I would recommend opening up what's called a private bug bounty first, with a limited scope. So basically what that means is you have a small number of researchers that you allow to poke around a certain part of your infrastructure. So you can test the waters a little bit. You can see what comes back. How bad is it? How many vulnerabilities do you get? How noisy is it? Can you handle it? Can you handle it with all your other competing priorities? If your experiment there, if you try it and it goes well, then you can gradually increase that scope, increase the size of the program, and over time you can work up bigger and bigger and bigger and bigger. And if you wanted to at some point go crazy with it and create a public bounty, then that's an option for you. But I would not suggest just jumping right into a public bounty with a wide open scope, because you might find that it burdens your team more than you were thinking, and it creates a really bad experience for researchers. And then having a bounty and then making it go away can actually also create a bad experience within the community.
That's awesome. And thank you for sharing that as well, because I think people may underestimate the overhead that may come with that as well. To your point, when you were doing this on Netflix, you guys were rotating it on an individual basis, like on a weekly basis as well, right? So you could be in a scenario where there's just so much information coming through. You're going, oh my God, I didn't expect this. Now I need to have a dedicated person who's looking at this.
Yeah, you have to understand at Netflix, they had a very large, mature application security team that had a PagerDuty schedule and had people that are dedicated to doing nothing but security. But at a smaller company that's considering bug bounty, it could look very different. You could just have people that are like, security is one of their responsibilities, but it's not their entire responsibility. Or you might have one person that's doing all kinds of different security, not just AppSec, depending on the size of the company and the maturity of their security program. And so it's really important to test the waters a little bit to understand what that burden is going to be before you go crazy and you start opening it wide up.
Yeah, awesome. And now since we have clarified a few things, we've kind of spoken about a few bugs that were there, and we also spoken about some of the challenges that people may get into if they start a bug bounty program without limiting the scope and not keeping it private. curious because a lot of the conversation that we had so far in terms of bugs have been primarily around lateral movement. And I'm curious to know from your comparison to, I guess, I'm going to put the notes of actually, I'm going to put the links to your talk onto the show notes as well, so people can go back to it and listen to the whole thing. Because you've done a great video just on the DEF CON thing, which is really interesting with the whiteboard and everything. I see a few whiteboards behind you as well. So I would definitely encourage people to check that out and have a look at the show notes for that. The question that I had is, compared to traditional, say, lateral movements between, say, a Microsoft Corporate Office 365 or whatever you're going to call it, how different would this be? Like, how does it compare?
Yeah, so in a traditional Microsoft environment, you have a sort of a domain controller, and an attacker breaks in at some part of the network, maybe through spear phishing, and they get access to a person's endpoint. And then you would use something like pass the hash to use the local admin administrator account to jump from that computer to other local computers. You might use something like a WPAD poisoning attack to get credentials and jump that way. And you just kind of dropping malware to malware to malware from system to system to system until finally you find a credential that's privileged enough, you can take over the domain controller and compromise the entire environment. In principle, all the words I just said are totally different in the cloud, but the concepts are actually really similar. You start with a credential, and it starts with presumably a low-level privilege, and you jump from that to another identity, to another identity, to another identity, just slowly collecting credentials like Pokemon cards, just like you would in a Microsoft environment, until eventually you find something that has full control of the organization, and then you win the game. The big difference is there are no private networks in the cloud. Everything is through a public API. There are no malware implants through the mechanisms that we talked about. You do everything by accessing that API with the credentials you find. And so it's very interesting that like the traditional Microsoft ways of lateral movement are through grabbing credentials and then running arbitrary code on systems to grab more credentials, to run more code, until eventually you compromise the entire environment. And we can do almost the exact same thing in a cloud environment without dropping a malware implant, without compromising running systems, all just hitting public APIs with static credentials that we find lying around.
Oh, I love it. I love the comparison, because now it's like old school meets new school in cloud versus on-premise. So, okay, cool. Wait, so does that mean, what we used to call as network security pen testing, that should be just called identity security testing, I guess, in the cloud world? I mean, I don't know. I'm just making up words here.
Yeah, I mean, so, if you want like a pen test, you could just call it offensive security, throw it all in one big bucket and not worry about it too much. If you're looking for an audit, then you might call it like identity or access control audit or cloud audit or something like that.
Because to your point, when you're running I guess what you're really trying to find is identity is becoming quite crucial in the cloud space versus, say, on an on-premise environment where network also is quite crucial, because you have your private network, closed network, and blah, blah, right? Okay, wow. I'm glad we kind of mentioned that as well. And maybe makes me think that the vulnerabilities that you found, and I'm sure if there's a public write-up on the whole Google's internal identity, I guess, identity access management space, does any of this give you access into the Google Cloud network, like as in like their own network, or is it like, how exposed are they with this?
Yeah, so Google has for a little while, and I've never worked at Google. All of the information I get about internal Google has fallen off a truck, we could say. Certainly didn't come from any friends or anything like that. It just fell off this one truck one time. Google for a little while has been working towards this thing called Corp to Cloud, where basically they're trying to move a lot of their old corporate data centers into their own Google Cloud ecosystem. They're basically dogfooding their own cloud product is another way of putting it. And we found from that truck IAM policies for internal Corp to Cloud projects. And we wrote about this in a public write-up. We found evidence of all of the vulnerabilities and lateral movement issues that we talked about in their talk apply to Google, the organization. And so what that means is if an attacker wanted to attack Google, from the limited snapshot that we were able to see of certain projects, that attacker would be able to use the same exact mechanisms that we documented work for every other organization we looked at, and they'd be able to compromise Google through the same lateral movement techniques that we talked about.
Oh, I just imagine an insider threat profile being created in Google Cloud for this. But it's that's an interesting way to put it. Because I'm actually one more point on that, because I think you guys mentioned this, because you don't see what permission you have access to, but there's a trick that you guys did. You copied the permission of an existing Google managed role onto a custom role. Can you talk a bit about that as well?
Yeah, so that kind of speaks back to what we said about Cloud Build, where sometimes there's these mystery identities that just fall out of the sky, and you're like, oh, well, what the heck is this thing, and what does it have access to? There was a trick that Allison found that allowed her to actually see what permissions that mystery identity had, and we talked about that in our B-Sides talk, and folks can check it out. But that's how we figured out it had access to buckets and artifacts and things like that, was through that trick.
Yeah, perfect. And I love that trick. I'm like, oh my God, yeah, like that. If they allow for that, that totally makes sense. So it's not technically hidden or quote unquote, but so I'm going to take a pause there, and I'm going to ask a very serious question now, because now you've scared people on Google Cloud and going. So what cloud do you recommend from your security perspective after all this?
Yeah, I get that question a lot, actually, and my answer to that is it's kind of a trick question, and I'm going to share a little bit of a story on why I think it's a trick question. I know a friend of mine is an executive over at Microsoft, and I had a conversation with him at some point. I was talking with him about internal Microsoft IAM, and they're very heavy Azure users, as you'd expect. And I said, at some point the conversation came up about Google Cloud, and I said, I'll bet that you have some people at Microsoft that are using Google Cloud. And he was very adamant that was not the case. He's like, what? We're Microsoft. Of course that's not the case. We're all Azure. And so, I challenged him a little bit. I bet him on it. I was like, I'll bet if you go and search for it, you will find a bunch of people internally. Like, you're going to tell me no one at Microsoft needs to use BigQuery. Like, no one at Microsoft needs to use the AI pipelines that Google. I mean, I'll bet if you go looking for it, you'll see some teams have opted to use Google Cloud. And he did. He went and looked and found that was, in fact, the case. There were some people that just needed BigQuery to do their job. They needed the AI APIs that Google offers to do their job. And so the reason why it's a trick question is if a cloud provider is multi-cloud, right? If a cloud provider that is Azure is their service, if they can't prevent other people from using other clouds, everything is going to be multi-cloud if it's not already. And we just need to accept that. And so that means, unfortunately, we all need to become experts in more than one cloud, and we need to be comfortable with our developers working in more than one cloud. And rather than trying to pretend that it doesn't exist, and then you end up with people throwing things on corp cards and nobody knows what's going on, we have to embrace it, enable those org policies on day one, set a policy for it, and just accept the reality that everything is multi-cloud.
Oh, it's an interesting insight. And I wonder, as you say this, someone's using AWS and Google Cloud because the compute engine is not good enough. I wonder if that's the case as well. But I'll let those people comment on that. I'm curious as well now, because we kind of spoke about a lot of the, I guess to your point, we went into some of the weeds of application security for some of these SSRF. We spoke about the blue team side as well. I'm curious, like people who may be listening to this and thinking, hey, I can do some bug bounty for Google Cloud as well. And like, but where do I start? Like, what kind of skill set am I looking for? Do I need to be like this network security expert, as Dylan was talking about, that I'm looking for jumping from one network to another? Or what are some of the skill sets that people can look to start with? And how low is the bar, I guess? Yeah,
so I kind of hinted about this a little bit earlier. Unfortunately, bug bounties in general have a barrier to entry. If you're not familiar with security vulnerabilities and you're just jumping in trying to do the basic bare minimum against the biggest companies, you're going to have a lot of competition, and it's going to be tricky. Somebody who I follow on Twitter, Vicky Lee, just posted about a new book that she wrote that's meant to teach people how to do bug bounty. It's called Bug Bounty Bootcamp. And if folks are thinking about getting into bug bounties, that's a good place to learn the basics. But what I found is if you really want to be successful, you have to find some niche that either speaks to your skill sets, some specialty that you are really good about, and just really research the heck out of that so that you are looking at stuff that other people aren't. Or you need to take advantage of private programs, and you need to once you do a couple of bug bounties, you'll start getting invites to private programs. And there's just much fewer people to compete with, and it's just a little bit easier to find some of the low-hanging fruit. So unfortunately, for folks that are new to bug bounty, currently there is a little bit of a skill gap, of like a barrier to entry. There's some good resources out there to kind of catch yourself up. But my recommendation is speak to your own skills, whatever they may be, whatever you're specialized at. Do your security research around that thing, because it'll just help make you stand out and help you look at an area that other researchers probably aren't taking as deep into.
I love it. And I think it's worthwhile calling out. People may underestimate their skill set. I think Zenith earlier mentioned identity. Identity is in itself such a broad space, and so much people can be doing in there as well. I think identity security in cloud has become a thing. Credential security has become a thing as well. And I would love to talk to you, I guess, if you can probably tell people about Truffle Security and what Trufflehog was all about as well. I would love that as well, man, if you don't mind sharing.
Yeah, no, I appreciate you asking. Trufflehog is a tool that I wrote a couple of years ago to help me do bug bounties, is the long story short. It helps find credentials that were accidentally put into Git. And I kind of just threw it up on the internet after I wrote it. It helped me find a couple of bug bounties. I gave it back to the community, hoping that there might be some other people that could make use of it. And I'm just so humbled by how many people have used Trufflehog to find credentials and make money off bug bounties. And it's been mentioned in like a book now, and I think it's taught in some universities. Trufflehog is an open source tool on GitHub that basically it helps you find credentials in Git. Truffle Security is a company that I recently built around it. That's just expanding on that community and building off the top of all the awesome people in the community that have used the tool.
Awesome. And I'll definitely recommend people to check that out as well, because Trufflehog, it may sound very, how do I put this? You may almost think that, hey, who puts credentials in GitHub? But people would be surprised how often that happens.
Cloud security is identity and access controls and secrets management. The second part of that, you got leaky secrets all over the place. You walk down a street in the San Francisco Bay Area, and you'll run into a credential by accident. They're leaking out left and right. So
awesome. Seems like people should, starting in bug bounty, should walk down the streets of San Francisco Bay Area. But I appreciate this, man. And I know we've kind of gone quite technical and towards the end of our conversation as well. So I've got 3 simple questions for you. So hopefully they're fun questions, and this way people get to know a bit more about you as well. First question. What do you spend most time on when you're not working on bug bounty or cloud or technology?
So I was warned that there would be 3 very tricky questions at the end. And so I've laid a trap, if that's okay. For every question you ask, I'd like to ask you a question back. Is that okay? And I'll answer it.
Yeah, I'll go for it, man.
All right. So the answer to the first question, honestly, is I've been so involved with this community building and this startup. That's really taking up most of my time. But otherwise, it's been sometimes doing work in politics, sometimes going for hikes. It's been a good blend of stuff. All right. Now I've got a question for you, if it's all right.
Sure.
My question is, being a member of the Australian security community, do you identify more as a flat duck or a tall duck?
I was gonna. Well, people, you should actually. Well, maybe once I answer it, you should probably let people. Wait, can we tell what flat duck? I think there's no PC requirement over here. You can definitely talk about. I think I'm a fat duck, man. Embarrassingly enough.
Thanks for your answer.
Do we need to tell people what fat duck is? Do we have to tell people what it is?
I don't even know what it is, to be honest with you.
I just
okay.
Know it's so I'm going to let people. Sorry.
Oh, I just know it's a very Australian hacker scene thing that everybody has picked their identity, and I just am very confused by it. But I love asking the question.
Perfect. It's a good question as well. Hopefully, I didn't embarrass myself in public, because unless the meanings have changed since the last time I heard about them, it'll be because COVID has made people not come out in public anymore. So it's been a year of not seeing person and hearing the updated definitions of such some terms. So hopefully I didn't embarrass myself by calling myself a fat duck. The second question that I have is, what is something that you're proud of but is not on your social media?
Yeah, so I mean, I was not on social media for a really long time. I just created my Twitter recently. It just is kind of a little lonely over there just because it's so new. But I guess, there's so much of the research that I've done was prior to social media. So the community that was built around Truffle Hog, I've really enjoyed that community, but it wasn't on social media at the time. The work I've done in politics, the companies that I've worked at, all that stuff was really before I created a Twitter, before I started posting things.
Awesome. And well, I would definitely link your Twitter account so you don't feel that lonely anymore, man. I think I'm pretty sure after this conversation, people would find they definitely should follow and connect with you and find out all the other interesting things you find on Google Cloud as well, or maybe other clouds.
Yeah, I appreciate
Last
that.
Question.
May I ask a question back at you really quick?
Go for it, man.
May we, and you can say no to this, may we see your dog?
Oh, you could. I actually logged him out. I was trying to see. We logged him up. Don't worry. He has an Instagram account, so he's all over that Instagram account.
Nice.
I'll share. I'll actually put that in the notes thing as well, because I definitely feel he has been getting a lot of attention lately, because he's one of those poodle mixes. So I love what you're doing, man. I love the fact that you're throwing a question at me as well. So I'm waiting for your next third question. So what is your favorite cuisine or restaurant that you can share?
Yeah. So recently I've been on a little bit of an Ethiopian binge. I know
injera bread and everything.
You can't eat enough injera. I'm always getting the extra and it fills me up. It's a sponge in my stomach, but it's delicious. I really like Ethiopian food, and lately I've been on a Ethiopian streak.
I love it. Do you get that whole big plate and everything? Like
especially
injera bread.
Back, before COVID, you get, a whole bunch of your friends. Everybody just shares this big, family style, lots of different stuff on the big injera. It's great. It's awesome. It's delicious. It's it's really special. So that's I'm sure that answer will change over time, but that's my recent answer.
That was a good answer, man. Because I think what someone told me, and I did not realize this, was there's a reason why a lot of the plates are round and not square. It's supposed to be like everyone coming together as a community. So imagine a square plate. There's only 4 people sitting around it, but if you surround one, then it's like you're growing your circle. That's where your circle kind of sits around. Like,
yeah, I love that.
Anyway, I'm going in a very different tangent. What's your third question now?
My third question for you is I heard that Melbourne has recently entered lockdown. So what is the first thing that you're going to do once Melbourne gets out of lockdown?
I'm going to go to a good coffee place and try some good coffee. I've been making, because Melbourne is known for coffee and food, and a lot of the restaurants are, the restriction rules are we cannot go beyond 5 kilometer or 10 kilometer from our house, which is probably the same as 3 to 7 miles from your house. Like, a lot of people may not have a lot of things around the 7 mile radius, not like a great restaurant sometimes. And unfortunately, I'm in one of those suburbs, I guess, where I have a few places, but after a week, you've tried all of them, right? So now you go into second week, you're like, oh, I wonder what that place was like, which was in downtown, and it was pretty good. But it's beyond 10 kilometers for me. So I'm looking forward to going for a good brunch. So great coffee and hopefully a good brunch item. That's what I'm looking forward to. but you might feel people might just be interested in giving hugs and like, I'm so glad I could see another person after the lockdown, because you almost don't see many people on the road as well. So
no, you're just like straight for the coffee. Yeah, you're like right. That's priorities, right?
Appreciate that, man. Great question, and I love what you did with your approach as well, man. Thanks so much for doing this. I'm conscious of your time as well. Where can people find you if they want to have any more follow-up questions with you? Where do you normally hang? LinkedIn, Twitter? If you want to put those in there as well for travel security as well, not just yourself.
I'm on Twitter now. Yeah. So Insecure Nature Twitter is myself. I think we set up a Truffle Security Twitter, but I need to learn how to Twitter. I'm still learning the ropes. I'm not new to it. I need somebody to help me. I need a shepherd to help me through the Truffle Security Valley, or the Twitter Valley. I'm on LinkedIn as well. I used to not be active there at all. I finally filled in the last couple of jobs that I worked at and actually did some stuff on LinkedIn. I'm available now. So folks are welcome to find me on LinkedIn, find me on Twitter, find me, wherever's convenient, and I'm available.
Awesome. And dude, thanks so much for coming in, man. I really appreciate it, because I think the research that you've done and everyone that Allison, and I think you mentioned Will as well, it's been really interesting to kind of hear that, oh my God, as a community, we're trying to make these things better as well. Even though the cloud service providers, oh, there you go, you got Zenith who will follow you as well. Thank you, Zenith. And I feel we just need more of these, and I hope someone got inspired listening to this conversation and may reach out to you, and or maybe even Zenith and other people would just be able to kind of look into this space a bit more, because how do you secure something without knowing how it can be exploited, right? So I appreciate you spending time with us.
Thank you so much for having me. We're all standing on the shoulders of giants. So I'm only, building on the top of previous people's research, and hopefully, like you mentioned, folks can build on the top of mine. Thanks so much for having me this morning. It was a blast. I really enjoyed the chat we had. No problem. Thanks for coming in. And for everyone else, feel free to, follow and subscribe to the channel, or if you're on LinkedIn, follow the channel, because this is where we post every weekend. And I will see you all in the next episode. Until then, stay safe and enjoy coffee. All right. See you, everyone. Bye.